Assalamualaikum and hi everyone. Jadi sesi kali ini kita akan lihat presentation para pelajar yang akan berkongsi ilmu bersama kawan-kawan bagi persediaan menghadapi final exam yang bakal tiba dalam sesi Dari Kita Untuk Kita. Jom kita tengok.
Hi everyone, I am Chan Jingyi from S15P11. Today I would like to present subtopic 9.2, Graph of Simple Harmonic Motion. So let's start. Let us start with the displacement against time graph. We had learning about the formula of displacement in previous subtopic, which is S equal to A sine omega t plus phase angle. Since the graph here is start with 0, we have no phase angle, so we can get this formula. In case our y-axis is start here, the graph we get is like this. It's a cos graph, so we can get the displacement formula as S equal to A cos omega t. How we can get the formula in terms of sine? Let's follow this rule. If the phase angle equal to negative value, means the axis is shift to the left. If the phase angle is positive value, means the x-axis is shift to the right. We can see obviously our y-axis is shift to the right, so our phase angle is positive value. We shift the y-axis in the angle of pi over 2 is positive, so we can get the formula in sine term is S equal to A sine omega t plus pi over 2. How about in case we get the axis like this? We can see obviously this is a negative sine graph, so we can get the formula as S equal to negative A sine omega t. We can get the second formula in sine term in this graph and follow this rule to get it. So we extend our negative x-axis first and continue the sine graph. Here is negative t minus 2. Let's change different color. Here is our y-axis, so our graph is right here. We can see obviously we have shift our y-axis to the left in the angle of negative pi. Why negative? We have shift the axis to the left, so it's negative value. So we can get the second formula of this kind of graph as S equal to A sine omega t minus pi. Second, let's learn about the velocity against time graph. How we can get the formula of this graph is differentiation of the formula of x. Let's see. The differentiation of x may start with differentiation of x times differentiation of the angle inside here. So the differentiation of sine we can get cos, and the differentiation of this omega t we just get omega, because we are differentiate in terms of t. So in the end we can get this formula by combine this and this. Let's continue with acceleration against time graph. How we can get the formula is differentiation of velocity. Let's see. We already get the formula of velocity as v equal to a omega cos omega t. Let's differentiation the velocity to get the formula of acceleration. So a equals to dv dt. We must differentiate the velocity in terms of t. So it's equal to times we should differentiate one more time the angle. So the differentiation of cos is equal to negative sign here, and differentiation of omega t is equal to omega. So let's time all of this and get the acceleration formula. Since the formula of acceleration is negative sign, our acceleration against time graph is upside down of sine graph. Next, let's learn about the energy against displacement graph. So we know the energy consists kinetic energy, potential energy as the total energy. So the formula of kinetic energy is K equal to 1 over 2 m omega square amplitude square minus y square. And the potential energy got formula of 1 over 2 m omega square y square. Let's see how we draft this graph. In the origin means y equal to 0. Let's sub the 0 into these two formula. When the y is equal to 0 means the potential energy also 0. So means this line is potential energy. When we sub the 0 into the kinetic energy formula, we get 1 over 2 m omega square a square. Means the graph is at the amplitude here. So means this line is kinetic energy. At this point, y is equal to positive a. Let's sub positive a into these two formula. We can get 0 kinetic energy since a square minus a square when the y is equal to positive a is equal to 0. So kinetic energy is 0. So here 0. Let's sub the positive a into the formula of potential energy. We can get the potential energy equal to 1 over 2 omega square a square. Means the point of potential energy is at the amplitude. So it's here. Same the situation in case here. Y equal to negative a. Let me do some example question. The graph below shows the velocity time graph of a body of mass 250 grams performing a simple harmonic motion. Determine its amplitude, the maximum force that acts on the body. So let's start with the amplitude. The formula of V is equal to A omega cos omega t. So it means the amplitude of the graph is A omega. So A omega is equal to 10. The highest point here. 10. So how we can find the amplitude? Actually, we can calculate the omega. From here, we can get the period, which is equal to 0.4. What the formula of omega is? Omega equal to 2 pi over t. So let's sub in. So we can get the amplitude here, which is 0.64 meter. Next, for the maximum force. The formula of maximum force is equal to m omega square amplitude. So here we get the mass, and the omega we have calculate in A, and the amplitude also. So let's sub it. 0.25 must change to unit SI unit. and the omega is 2 pi over 0.4 square. Amplitude is 0.64. So it is equal to 39.5 Newton. Let's do example 2. The graph shows the simple harmonic acceleration time graph of a 0.5 kg mass attached to a spring on a smooth horizontal surface. Use the graph to determine the spring constant, the amplitude of oscillation, the equation of displacement S varies with time t. Let's start with spring constant. We already know the formula of acceleration against time graph is A equal to A omega square sine omega t. So how we get the omega? Omega is 2 pi over t. We can get our t here. For a complete course, we know the period is 0.8. So we get the omega as 2.5 pi. Since we get the omega is 2.5 pi, so we can calculate the spring constant because the formula of spring constant equal to m omega square. So it's 0.5 and 2.5 pi square. So we get the spring constant as Let's continue with calculate the amplitude. We already know the formula of A. So the amplitude of the graph is A omega square. We get the higher point here is equal to 2. So we get the value of omega in the first question. Let's sub in. So in the end we get the amplitude. Finish. Next, find the equation of displacement x varies with time. So the formula is S equal to A cos omega t. Why cos? Because as usual, our acceleration graph is negative sign. Here we got the acceleration against time graph as a cos. So with integration to velocity, we will get sine. And integration to displacement against time graph, we get cos. So that's why our formula of x is A cos alpha t here. So we already determined the value of amplitude and also the omega. So let's sub in. So the formula is A equal to 0.0324 cos 2.5 pi t. We have finished this question. Let's continue with the last example question. Figure 4 shows a displacement against time graph of simple harmonic motion. Determine the amplitude, frequency, angular velocity, and the equation for the simple harmonic motion. So for the first, amplitude is obviously right here. So our amplitude is 5. Next, the frequency. The frequency got a formula 1 over period. We can get the period in our graph right here. For a complete sine curve is 4. So it's equal to 1 over 4 and equal to 0.25 Hertz. Don't forget to write unit here also, cm. Next, determine the angular velocity. Angular velocity equal to 2 pi over d. So it's equal to 2 pi over 4 is mean 1.57 radian per second. Or you want to write in fraction form is mean 0 and also equal to 0.5 pi. And the last, determine the equation for the simple harmonic motion. So the formula is equal to S equal to A sine omega t. We already get the amplitude as 5 cm and the omega equal to 0.5 pi. Let's sub in. So this is the answer for the last question. That's all for me. All the best for your PSPM. Thank you.
Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Hai, nama saya Nur Atira binti Muhammad Razi. Hari ini saya akan bentangkan tajuk 9.3 iaitu Period of Simple Harmonic Motion. At the end of this topic, students should be able to use expression for period of simple pendulum and single spring. Dalam tajuk ini kita ada dua formula yang digunakan untuk kira simple pendulum iaitu T sama dengan 2 pi punca kuasa L over G dan juga single spring T equal to 2 pi square root M over K. Sebelum tu kita kena faham apakah itu simple harmonic motion. So, simple harmonic motion is the special type of periodic motion where the restoring force on the moving object is directly proportional to the object displacement magnitude and act toward the object equilibrium position. So maksud dia kat sini, simple harmonic motion tu ialah is a special type of periodic motion. Periodic motion tu maksudnya repeated motion where the restoring force on the moving object is directly proportional. Okey, untuk kira the period of simple pendulum ni, dia mesti ada syarat-syarat yang to execute SHM. So ada 3 syarat iaitu first, the angle has to be small, less than 10 degrees. Second, the strain has to be inelastic and light. And third, only the gravitational force and tension in the string acting on the simple pendulum. Ini adalah formula bagi the period of simple pendulum. T equals to 2 pi square root L over G. T is the period of the simple pendulum, L is the length of the string, and G is gravitational acceleration. Ini adalah syarat-syarat for the spring mass system execute SHM. So, dia ada 3 syarat. First, the elastic limit of the spring is not exist when the spring is being pulled. Second, the spring is light and obey the Hooke's law. And third is no air resistant and surface friction. So ini adalah dia punya formula untuk kira the period of single spring, which is T equal to 2 pi square root M over K. T is the period of simple pendulum, M is the mass of the object, and K is the spring constant. So sekarang kita try buat latihan yang berkaitan dengan period of the pendulum. Okay, soalan yang pertama. A pendulum with a mass of 0.25 kg has the period of 1.15 second. If the initial displacement of pendulum is 20 degrees, what is the length of the pendulum? So dia bagi kat sini, kat maklumat tu ialah mass dia ialah 0.25 kg. So dia dah bagi masa iaitu T equal to 1.15 second. So kat soalan dia minta apakah the length of the pendulum. So sebagaimana kita tahu, yang formula bagi untuk kira the period of the simple pendulum ialah T equal to 2 pi square root L over G. So sekarang dia nak kira length. Dia suruh kita mencari berapakah length of the pendulum. So kita adjust soalan formula tu, kita jadikan L sebagai objektif dia. So kita kita kuasa 2 both side untuk hilangkan punca kuasa dekat formula. After that, kita bawa G naik atas. So akan dapat T kuasa 2 G sama dengan 4 pi kuasa 2 L. So kita pindahkan 4 pi kuasa 2 tu kat sebelah. So akan dapatlah L sama dengan T kuasa 2 G per dengan 4 pi kuasa 2. Lepas tu kan dia dah bagi apa dia punya T dia ialah 1.15 dengan juga kita tahu juga G sama dengan 9.81 kan. So kita masukkan dia dalam formula. So dah lepas masukkan, so kita akan dapat L sama dengan 0.33 meter. Soalan seterusnya. What is the length of the simple pendulum has a period of 1 second? So kita dia suruh kira length of the simple pendulum, tapi dia dah bagi masa dia T equal to 1 second. So kita guna balik formula yang first tadi, L equal to T power of 2G over 4 pi power of 2. Kita gunakan formula tu, lepas tu kita gantikan T tu dengan 1 second. So lepas dah ganti masuk, akan dapat L equal to 0.25 meter. Soalan yang kedua yang berkaitan dengan period of the pendulum. What is the period and frequency of the simple pendulum that has a length of 1.10 meter? So dia suruh kita kira period and frequency. So kita gunakan formula the period of simple pendulum iaitu T equal to 2 pi square root L over G. So dia dah bagi dia punya length dia ialah 1.10 meter. So kita gantikan masuk dalam dia. G equal to 9.81. Lepas tu kita dapatlah T dia equal to 2.10 second. So yang kedua dia suruh kita cari frekuensi. So formula bagi frekuensi ialah F equal to 1 over T. So kita gantikanlah jawapan yang kita dapat tadi, T equal to 2.10 second tu ke dalam formula. So dapatlah frekuensi dia ialah 0.48 Hz. Seterusnya, soalan ni berkait dengan formula period of the spring. So soalan yang pertama, What is the period and frequency of an oscillating spring K equal to 10 N/m with a 200 G mass attached to it? So kat soalan ni kita senaraikan dulu maklumat yang dia dah bagi. So dia dah bagi K dia ialah 10 dan mass dia dalam gram kan, 200 gram kan. So kita tukarkan 200 gram tu kepada kg. So kita bahagikan dengan 1000, dapatlah 0.2 kg. So seterusnya kita akan masukkan dalam formula period of the spring, iaitu T sama dengan 2 pi punca kuasa M over K. So mass ni kita dah tukarkan kepada kg, so kita masukkanlah dalam formula. So dapatlah T dia equal to 0.89 second. So yang kedua dia suruh cari frekuensi. Frekuensi kita tahu formula dia 1/T kan. So kita gantikanlah masuk jawapan T yang kita dapat tadi dalam formula frekuensi. So kita dapatlah F sama dengan 1/0.3 Hz. So seterusnya period of the yang berkaitan formula yang berkaitan dengan period of the spring. A child in a bouncy swing is suspended from a spring. If the spring stretch 50 cm when 8.5 kg child is put in it, what is its spring constant and how much time does it take for the child to complete one bounce? So dalam soalan ni kan berkaitan dengan single spring. So tadi kan kita ada 3 syarat yang mematuhi yang patut dipatuhi untuk kira period of the spring kan. So salah satunya mesti obey the Hooke's law. So kita gunakan formula Hooke's law, F equal to negative kx2, sebab dia kat soalan dia minta what is the spring constant. So kita arrangekan formula Hooke's law tu, akan dapat K equal to F over X. So formula bagi F ialah F sama dengan MA. So mass kita ada, A pun kita ada, so X pun kita ada. Cuma X tu kan dalam sentimeter, so kita tukarkan 15 cm tu kepada meter. So kita masukkanlah dalam formula dia lepas kita arrangekan F tu. Maksudnya kan kita arrangekan equation Hooke's law tu kan, dapatlah formula K equal to F over X. So kita masukkanlah dalam formula dia F over X tu. So akan dapat K equal to 556 N over M. Soalan yang kedua, how much bukan soalan yang kedua, maksudnya soalan tu dia minta dua kan, iaitu spring constant dengan juga how much time does it take for the child to complete one bounce. So untuk soalan yang how much time does it take for the child to complete one bounce tu, so kita gunakan formula the period of single spring tu, T equal to 2 pi square root M over K. So kita gantikanlah masuk mass dia kita dapat, K pun tadi kita dah kira, iaitu 556 tu kita masukkan dalam formula. So dapatlah T sama dengan 0.78 second. Okey, itu sahaja daripada saya. Sekian, terima kasih.